You know, we trust doctors with our lives, literally. So, how do we make absolutely sure they're ready for that huge responsibility? I mean, before they ever treat a real patient, they have to be tested over and over again. The stakes? They really couldn't be any higher. So, that leads us to this really big question. Think about it. You would never want a pilot flying a 747 if they hadn't spent hundreds of hours in a flight simulator, right? So, how do you create that flight simulator for a doctor? How can you possibly test their real world skills, diagnosing a problem, communicating with a scared patient, performing under pressure in a way that's realistic, but also totally fair? All right, let's get into it. For a long time now, the best answer we've had to that question is this really groundbreaking type of exam. It's called the OSCE, and honestly, it completely revolutionized how we measure a doctor's practical skills. So the OSCE, which stands for Objective Structured Clinical Examination, it's basically a high-stakes medical obstacle course. Instead of just, multiple choice test, students have to physically move through a circuit of different stations, and in each one, they're faced with a standardized patient. That's an actor who's been trained to perfectly mimic a real medical condition, and they have to perform a specific task. The whole point is to make the evaluation objective and standardized, a true test of what they can do. And this right here gives you a great visual of what that's like. Just imagine you're the student. A bell rings, you've got, say, 8 minutes at the psychiatry station to figure out a patient's mood. Then ding, the bell rings again, and you're sprinting to the cardiology station to read an EKG. It's this intense marathon of skill and focus, really designed to see how you hold up under the exact kind of pressure you're going to face in a real hospital. Now, the OSCE was a brilliant idea, for sure. But it's a system that is run entirely by people. You've got human patients, human graders, human organizers, and, well, wherever you have humans, you're eventually going to run into human limitations. Some cracks start to appear in the system. And this table here lays out those trade-offs perfectly. On the one hand, in the strengths column, you see exactly what you want. It's objective and authentic. Great. But then you look at the weaknesses, and whoa, they are significant. These exams are incredibly expensive and take a ton of time and effort to organize. You need a massive physical space, tons of trained actors, a whole team of expert doctors to be the evaluators, and this is the big one, look at that last point, evaluator fatigue. They just get tired. And that fatigue is a huge problem. It leads to all these other challenges with manual grading. I mean, think about an expert who has to grade dozens or maybe even hundreds of these student reports. Is their judgment really the same at 5 p.m. as it was at 9 a.m.? Probably not. And that can lead to inconsistent scores, maybe a little subjective interpretation creeping in. Plus, the students are stuck waiting forever to get their results. The system works, but you can see it's really straining at the seam. So this is where the story gets really, really interesting. What if you could tackle all those problems, the fatigue, the inconsistency, the cost, the speed, with one elegant solution? What if the grader wasn't human at all? Let's see what happens when AI steps into the exam room. A recent study decided to put this to the test. They took 96 of these detailed clinical reports written by real medical students during an OSCE, and they fed them to a GPT-4 AI model to grade. And the time it took? Just 24 minutes. Okay, but now for the real jaw-dropper. How long did it take a human expert, a real doctor, to grade that exact same stack of 96 reports? Somewhere between 2 and 4 hours. The AI wasn't just a little bit faster. We're talking a whole different league of speed. But look, speed doesn't mean anything if it's not accurate, right? So how did the AI's grading actually stack up? This is where it gets fascinating. On the one hand, the AI was perfectly consistent. It never got tired, it never had a bad day, its standards never changed. But it was also way, way stricter. The average score the AI gave was a lot lower than the human expert's average. And why? Well, because the AI follows the checklist to the absolute letter. A human grader can kind of infer what a student meant to say. The AI needs it spelled out word for word. And this 3.51 point difference is everything. It makes you ask the question, is the AI strictness a bug or is it actually a feature? For instance, if a checklist item said the student needed to mention coronary syndrome/osteochondritis, a human might give you the point if you just mentioned one of them. The AI, nope, it demanded both. So yeah, on one hand, it lacks that human nuance, but on the other hand, does that absolute consistency force students to be more precise, more thorough, and maybe, just maybe, make them better doctors in the long run? It's a really interesting question.
And you have to understand, this technology is about so much more than just grading an exam a little faster. This is about completely rethinking how we train doctors, right from the very beginning.
What AI really unlocks is this incredibly powerful, continuous feedback loop. Imagine a student can practice a difficult clinical scenario with an AI-driven virtual patient at 2 in the morning. The second they're done, bam, the AI gives them instant, data-driven feedback on how they did, what went well, where they stumbled, what key question they forgot to ask. Then they can review that feedback and try again, immediately. They just repeat that cycle until they've mastered it. This isn't just about passing a test anymore, it's about building the muscle memory for excellence. So, what does this future of medical training actually look like? Well, think about AI patient simulations being available 24/7. This could democratize access for students who are in remote or underserved areas. The AI can give personalized feedback that targets each student's specific weak spots, almost like a private tutor. It can even crunch the data to help schools predict which students might need extra help. And these virtual patients aren't just robots. You can program them to show emotion, testing a student's ability to show empathy, a skill that is famously difficult to teach. And this quote from Neural Consult just nails it. It says, "The shift isn't just about efficiency. It's about preparing future clinicians for an era where technology and human judgment coexist seamlessly." That's it, right there. This isn't just a tech upgrade. We're preparing doctors for the actual future of medicine, where their own expert judgment will constantly work alongside powerful technology. So what's the end game here? Is it a future where AI robots are grading all the exams and training all the doctors? No, not right. The real path forward, the one that seems most promising, is a collaborative one. And let's be super clear about this. The goal is not to replace the incredible experience and intuition of a human expert. The goal is to enhance it. It's about building a tool that frees them up from the tedious, repetitive parts of the job so they can focus on what humans do best: mentoring, providing context, and making those really complex judgment calls. This whole idea is known as the human-in-the-loop model. In this system, the AI does the first heavy lifting pass of grading. It can score everything based on those strict criteria and flag any potential issues. But, and this is the important part, a human expert always has the final say. They oversee the AI's work, they validate the findings, and they make the ultimate decision. That's how you ensure fairness, ethical accountability, and that nuanced understanding that, right now, only a human can bring. And that brings us to one last big thought to leave you with. We're seeing how this tech can help us train better doctors, people we trust with our health. So where else could we apply this? How could these AI-driven simulations and feedback loops help us train our pilots, our firefighters, our engineers, our teachers? The exam room, it seems, is really just the beginning.